All right, so I am Kristen Finch. I'm the Director of Research Computing Solutions here at UWIT. And the job of my team is to make sure that users can use our UWIT research computing services efficiently and have no problems with that. We also provide the technical support and maintain the systems. So today we're going to talk about, I'm just going to remind you of the services that we have at UWIT Research Computing, tell you a little bit of about what Hyak is and what Tillicum is. If you've heard about it, if you haven't, then you'll learn a bunch. And if you're new to Hyak, we'll give you some need to knows. We'll tell you about the Research Computing Club if you're a student, and we'll tell you where to find additional learning resources, and then we'll get into the hands-on tutorial. So UWIT Research Computing provides a number of research computing services. One is the Hyak supercomputer Clone, which is what we'll be focused on today. This tutorial is going to be focused on Clone, but where applicable, I might mention some differences that will allow you to adapt this to Tillicum and potentially other systems as well. Linux is uh, pretty universal in the high performance computing space. And so if you learn these skills, then you could be able to translate that to other systems that you use in the future for your research. We also provide storage services. We have a COPA out of object storage. It's based on S3 storage. And we have a Lobo tape archive. So this is a physical archive where you can cold store data, and it's geographically redundant in Seattle and out in the Tri-Cities. We also resell cloud computing services from AWS, GCP, and Microsoft Azure, and we have options for secure computing if your grant means that you or regulates the data that you're able to use and says that you need to have a more strict computing environment. We have some options for you there, and we provide consulting on all of these services. So the main star of today is Hyak Klone, which is the third generation of our Hyak supercomputing group of clusters. It's a traditional high performance computing cluster. This means that it's many, many computers all interlinked together with a network and also going out to the internet so that we can all access it remotely. And this allows you to perform tasks that would be too difficult or take too much of your RAM and compute on your local device. So maybe you found yourself here because you have some software that you want to use and you're tired of giving your computer to that software, to that work for an entire day, for example. We can help you to get this set up on supercomputer if it is applicable to your applications. And then you can make use of the supercomputer and hopefully make your work more efficient. It also allows you to do parallel computing, which means that you can execute the same task across, maybe if you have multiple samples, if you're applying the same command to many, many different systems, you can do those things in parallel, rapidly increasing your time and optimization on work. And really, the key here is that we maintain the system for you so that you don't have to think about those things if you're running a research lab. This is a shared computing service that is partially subsidized by the university. All right, and one thing to note, it is a condo model, so if your labs are interested in having priority access to Clone, they can purchase hardware through us, and that's when they get the priority on-demand access to their own set of resources, and that's shared among however many researchers you have in your lab. The hardware comes with some storage built in, but we do have community storage, and I'll be discussing more of the storage locations that you have available to you. And one really great thing about the Hyak ecosystem is that even if you're not a owner of that hardware, you do have access to the community idle resources in a partition called checkpoint. So when those labs that purchase those resources to add to the cluster are not using them, then they're available for you to schedule your jobs there. They're a little bit more limited. They have a time limit and your job could be preempted. So if the owners of those resources do need that, then your job could be kicked back to the line. But we find that this is a really great benefit to the community and makes sure that the cluster doesn't remain idle for too long. And at our latest count, we have over 37,000 compute cores and over 860 GPU cards as part of this supercomputer. And then our new service, Tillicum, was launched in October 15th. It is our new next generation GPU computing platform designed to support any type of research that you are doing, whether it be AI, machine learning, data science, scientific simulation, in all the domains listed here. And we are ranked in the world for sustainability and performance. We're number 185 on the top 500 fastest computers worldwide, and number 51 for power efficiency. That's called the Green 500 list. And then out of the United States academic supercomputers that are on this list, we're number 7. It's pretty sweet. And these are some of the stats so far since October 15th. We've had over 4,000 GPU hours. This is a compute or a usage-based cluster. So if you're finding that your research needs GPUs, or if you just want to explore GPUs, it's a very flexible payment plan that you just pay as you go. So it's not the star of today, but just so you know, it has 24 H200 servers. Each of those have 8 GPU cards. These GPU cards each have 141 gigabytes of RAM, so it's very high capacity. It's very fast. It is brand shiny new and really awesome if you get a chance. And if your lab needs that, please reach out to us. So you might have a number of computing tasks. Of course, artificial intelligence is a big topic at the university, learning about it, training new models, learning about human interactions with artificial intelligence is something that we can support at UWIT Research Computing, as well as GPU accelerated workflows. So we're finding more and more that different scientific applications can be accelerated with GPUs if they can be adapted to use that. Additionally, we do have the capacity to allow interactive workflows. So I'll show you a platform that you can use to start up a Jupyter notebook, for example, on Hyak Klone or Tillicum. And we support common data sets on Hyak Klone and Tillicum. These are data sets that are publicly available that folks have recommended that we host since they will be commonly used by many labs. So how many of you are new to Hyak, meaning that you probably have logged in or have not logged in but haven't done too much yet? Okay, so most of us, okay. So need to know is that Hyak is a paid and a community resource. Like I said, labs can pay to have their priority access, but anyone can use this and the community idle resources. You might have to plan your work ahead and set up your scripting to be automatic and unsupervised, but you can use this service for free. Hyak is run by a small but mighty team. So I think our entire team is maybe 15 people, but the folks that are primarily answering support tickets and stuff are like 3 of us. Sometimes we have more, and we do have a team of engineers that are supporting the actual infrastructure that we can call on. But we really value our relationship with you. It is our job to make sure that this all runs smoothly and that you know what you're doing. You feel confident about this. Kai Chen, who's my helper here today, is our HPC staff scientist, and myself, we used to be postdocs here at University of Washington in biology department and material science and engineering, so we know what it's like to be a researcher here and what it's like to move into needing computing more and more for your research, and that this is really an extracurricular for a lot of you. We want to make sure that goes smoothly. So to request support, we have also this PDF is available on the GitHub repository, and everything underlined is a link so you can explore these on your own after. We do have a support request form that you can choose any of our services to ask for help, or you can just email help@uw.edu with Hyak in the subject line, and that will send a ticket to us, and we'll be able to help you as a team. So like I said, we have a help desk. We also hold weekly office hours. Our office hour is today at 2 p.m. just out of the lounge here at eScience. And then on Wednesdays, we have a virtual Zoom office hours at 2 p.m. And we have several office hours hosted by the Research Computing Club, which I'll talk about in a little while. So Hyak Klone and Tillicum, this is a key point, um, is that they're offline the second Tuesday of each month unless we notify you otherwise. This is for regular maintenance, and we have a mailing list where you can get emails that remind you of this, so you're not, trying to log in and wondering uh, why you've been locked out. And finally, like I said, we do have demonstration accounts. If you have registered um, for this workshop today, I set you up with a special account for your training that you can use over this weekend, but I've also signed you up for a demonstration account. So just by being here, you'll remain having access to continue using Hyak. And then students are eligible for a free priority access account to use resources funded by the Student Technology Fee. And this is through the Research Computing Club. And just a little bit about them, they have many, I would say the students are actually one of the biggest resource owners on the supercomputer, and you have access to 26 compute nodes, 24 GPU cards, priority job scheduling, and computing storage there. I also have a cloud credits program with AWS. So if you're interested in having some money from AWS and trying out computing there, then that's available as well. They run a Slack community where you can get advice from your peers, but also Kai-Chen and I check the Slack on a regular basis. So we informally answer requests on that platform as well. And I post a lot of updates there about the events that we're holding, any jobs or fellowships that I hear about in the university or in the broader computing community. And they have special events like a hackathon. We're talking to IBM about a spring hackathon coming up in quantum, if you're interested in that. And we had an AWS game day this fall, which I thought it looked really fun. I didn't participate, but it looked really fun. And you got AWS swag and additional cloud computing credits if you were a winner. But it was like a competition-based hackathon where you could compete with your friends to help a fictional company called Unicorn Rentals. They say that they have a new game day that will be participating with them in the future. All right. So additional to those need to know is these are the big ones. So software on Hyak. Hyak is a shared research computing environment. We have a baseline computing environment. That means that we are not able to give root or sudo access to folks to be able to install their things as an admin would, because that could break things for others. But while it's the responsibility of a researcher to install this, and we have specific tools that we won't it's out of scope for this training, but we do have some other trainings coming up where that is more discussed. We are available to help you. So if you do have something that you don't see on Hyak, or you're having trouble installing it with the methods that you can use, then help request to us or come to office hours. Talk to us about it. All right, and then Hyak Klone is a Rocky Linux environment with a job scheduler called Slurm. Also a bit out of scope for this training, but it's free. We'll be doing a Slurm training. Again, we do have an interactive open-on-demand platform. We have Jupyter notebooks. I also forgot to change the slide that we have VS Code available there. RStudio. These are things that you can be using as you would through your browser, but it has a supercomputer behind it. There are modules for your software and custom Python environments. So this is just a snapshot into the open-on-demand environment. So just like you'd use in Jupyter Lab, you have your Jupyter notebook, but then you have your file system, which is your directory on Clone, which I'll talk about, but it's running through your browser. It's the fastest way to use these graphical interfaces. All right, lastly, storage management is key on our last need to know. So on Hyak Klone, you have 3 storage spaces that you should be aware of. And the first and most critical one, it's your home directory, which we will get into once we start the hands-on. But it's the first place that you are spun into when you log in to Hyak Klone, and you have 10 gigabytes there. So we recommend not storing anything there except critical configuration files and maybe some small files. But if you run out of storage in that space, you're immediately stopped from moving forward. And it's a very common um, troubleshooting that we do with our users because they run out of storage there. So let's just keep that in mind. I'll be showing you other storage spaces during the hands-on portion of this that you can use more safely. One of them is if you have a dedicated project storage from your lab, from the Research Computing Club, then you have a higher quota there and you can have your dedicated storage space for your long-term code bases and your data sets. And then we also have a free community storage, but this is temporary. It's in a directory called Scrub, and it's based on the access and modification time of those files. After 21 days of inactivity, they will be automatically erased. So keep that in mind. But one very nice thing is that we have Globus endpoint set up on Hyak Klone, and this is the best way to transfer your data onto the supercomputer and back to your local computer and other places. Okay, so how do you get started? Well, you're in the right place so far, because this is the first step in onboarding to use Hyak Klone is learning about the environment. But you should know that we also have additional regular training opportunities. We have an events calendar, and in the Research Computing Club Slack community, we post announcements about that. The Research Computing Club also has an Instagram where we're posting our announcements, and if they're shared to the UWIT Instagram. So if you occupy that space, that could be a good medium for you to find out about this. But the general UW Seattle events calendar picks up our events. This winter, we have this workshop, which is happening right now, but we also have a using R and R Studio on Hyak workshop. This is not an R programming workshop, but it's how to use R and R Studio with Hyak supercomputer behind it. And then we have managing Python environments with Conda and Jupyter on March 5th. And this one, I think, if you are going to use Python, you'll want to definitely mark your calendar for that, because we'll be giving you the best practices and the ways that we recommend to use Conda and Jupyter on Hyak Klone for your reproducible science. And finally, eScience, where you are right now, they also have their own set of events. I don't think they're having pixel proficiency this term, but they are having software-carpentry, I think, in a few weeks. This is where you can learn similar techniques that you'll see today, but also more Python skills and Arc skills. And they have a newsletter, which you can find on their website and sign up for that. All right. We have documentation for all of our tools, most of our tools on Hyak Klone. So these are the most common issues and things that our users will be running into. You can find step-by-step guides for those, and we have a monthly blog post with any updates. And we have links to our support and services there. We also have our Learn page with our learning resources where you can find short how-to videos and full length tutorials, and that's where this one will be posted later. So today, the rest of today, what we're going to do is we're going to run a tutorial. We're going to talk about the Linux command line, or CLI interface for HPC, high performance computing environments. We're going to log into Hyak. We're going to navigate the file system using core commands. We're going to talk about storage. I'm going to show you open-ondemand, show you how to transfer files, and then some more essential commands. I'm just going to go as far as I can with this. It is a longer tutorial. You do have the opportunity to do this fully on your own. So if you would rather go through step-by-step following the repo independently, that is an option. But if you like to have the hands-on, I'm just going to go through all of it that I can. You might get some more improvised things that you might not see going on your own. And we have a survey feedback link. I'll put that up later and send it to you in a reminder email as well. So please do give us feedback on how this went for you today. But a few last need to knows for your Hyak Klone training access period associated with today. So you are able, like I said, to complete this workshop whenever you want. And I've set all of you up who have registered with the demonstration account. That is a time unlimited account. You can continue to use it after this. If you're a student, you should look into student technology fee accounts with the Research Computing Club. But specifically for today, I've added you all to the UWIT account group. So over the weekend, you will have priority access also to UWIT resources. And so you can test things out. You can kind of see what it's like to be a priority user if you haven't had that opportunity before. And if that's something that your lab is interested in, um, do pass it on to us and let us know. We can talk to whoever we need to talk to if it looks like it's something that will accelerate your research. So this tutorial is designed for introductory concepts and practice, but then it's going to be followed by a task that connects multiple skills. And like I said, there's a lot. And so hopefully we'll get to all of it, but we'll see. Please interrupt me during this next section at any time to ask questions. Same goes on Zoom. We have Kai-Chen monitoring Zoom chat, but you can also unmute to ask for clarification about something. This PDF presentation is on the GitHub repository, and there's this page with all the links that you could ever want to all the things that I've mentioned so far. On the GitHub repository, I've written the address to it on the board over there, and Kai-Chen, if you could post that into the chat. This is where you'll find information that we'll go over for today's tutorial. We have this video recording. There'll be a post-produced video posted as a link here to YouTube. And the feedback form link is here as well. The sections are broken down into prerequisites, logging in, and all of the other things. The commands mostly start in 6 and 7, and there are some slightly more challenging, probably not for y'all are all very smart, more challenging questions in there. I didn't give all the answers on the task. All right. So I'm going to get this all set up. What I want you to have in front of you is your SSH client or your method to log in to the Linux system on Hyak Klone. So I'm a Mac user. I'm using the terminal to log in. Terminal is a built-in utility. On Windows, there's several options for you: Windows PowerShell, Command Prompt, and then there's some other ones that folks like to use that can turn your Windows system into feeling more like it's a Linux system, like Windows Subsystem for Linux and Git Bash. All right, so I'm going to go ahead and log in. SSH using my NetID. You should put your own NetID here at clone.hyak.uw.edu. And this asks for my password. While you're typing, your password will not show. Oh, our supercomputer, if you haven't noticed, requires Duo two-factor authentication. Did everyone have fine time logging in? Just so you know, if you mess up your password 5 times in 5 minutes, then you will be locked out for 1 hour. It doesn't IP address ban. It looks like it's a potential cyber attack. If you are impatient and if we are responsive on our tickets fast enough, then you can ask us to break you free of IP jail. Just let us know. All right, so now that you've logged into Hyak Klone, you see our message of the day. It reminds you where our documentation is, and it reminds you to email help@uw.edu, and that we have our monthly maintenance, and you can see when the reservations are for maintenance. If you copy this command, show res, February 10th is our next maintenance, so it tells you the time It's usually we go from 9 a.m. until around 4. We like to go home on time. You want to clear that off for your screen? You can use Command Clear. So one key concept of using a Linux command line is your location on the system. So right now I have just logged in and I have been brought to the login node. This is the front door of the system. Everyone passes through this node before they go into one of the compute nodes where the actual computing happens. So we have 2 login nodes, login 3 or login 1, and there are regulated system or operations that you could do. So we have a tool called Arbiter that actually cuts down on processes that would potentially make the login node unstable or prevent other users from being able to log in. And this will manually, or it kind of automatically slows down your processes, or it could kill your process outright. And that's just a reminder that you should use the compute node to do any heavy operations. But things that are allowed on the login node are text editing, file and data transfers, minimal operations, minimal installations of software, but anything beyond that, you want to be on one of the compute nodes. Another thing that you get from your first command prompts is you're reminded of who you are and where you are. So it says that on the clone login node, if you change to another computer, you can see that this will change. And then the last part of this, a shorthand for your home directory. Yes.
Oh, I'm sorry. No worries. How, after you log in, how long are you logged in? Is it once you like quit your terminal? Is there a timeout?
Yeah, there can be a timeout. So the default login time, I think it varies, but if you like close your computer and you cut off the internet, that will log you out automatically usually. I think I'm not sure what the default logout time for SSH is, but it's kind of constantly pinging the server to make sure that there's activity there. But if it sees that there is no activity, it will log you out. We do have a special protocol where you can set up a configuration that will, especially for Macs, it can extend your server alive time. So it lengthens that like threshold of time before it logs you out automatically. I have that set up for myself. And we recommend that for folks that are like kind of annoyed because they continue to work, but they look away for a second and their connection maybe wafers. That is, if I go to in our documentation, we actually have it under the VS Code because it's a critical part of setting up the VS Code proxy jump. And it's this first section about configure your SSH. You use the server alive intervals, and that will increase the amount of time before receiving a ping back from the server before logging you out. So I would recommend if you are frustrated by the logouts that you set that up. All right, so when you open into the server, you're in your home directory. The little tilde here is a shorthand for home directory, and as you move through the system in different directories, then you are that will change. So we'll show you your location. So you have a location on the computer or the server that you are looking into using the shell, which is like your window into the system. And you also have a location where you're kind of standing in the files. The one thing to note is that on your like Macintosh computer, for example, or your Windows computer, you have this Finder window, for example. I can click into these different places, and the command that's happening is it's in the background, it's opening up a directory or a folder. So usually in graphical systems, it's called a folder, whereas in Linux systems, it's called a directory. So by clicking, I'm actually issuing the commands that we're going to run through today. So if you keep this kind of mental picture in your mind of Hyak has, a non-graphical file system, I can, instead of clicking, I can, step through these directories and see what is there, but using commands. And this simplifies, it kind of strips down everything that you're doing into its bare parts, and it makes things like automation, scripting, possible and more efficient. So let's go ahead and see a little bit about where we are. So the first command that I want to tell you about is called pwd, or print working directory. This command gives you your absolute path of wherever you are in your current directory at the time that you issued the command. So I am in MMSFS1. That's like the baseline directory of our mounted file system, which is the cluster that is attached to Hyak Klone, which holds all of the data. And I'm in the home directory. This is where all of everyone's home directories live. And I have home directory with my UWNet ID, BingeKN, and all of you have one with your UWNet ID. So that's where you are. So I can use another command called ls to list the contents of my home directory. So if you are just starting to use Hyak, you probably don't have very much in here. I have a lot of things from being messy and testing all of the stuff that I need to make tutorials. But this is how you would be able to see what is in any directory where you issue the command. You can use ls-l to give you the longer version of what this is. It tells you the permission structure around this. So what you can do or what everyone else can do. You have permissions for yourself, for your group, and for everyone. And then you have some information about the size of your files in megabytes. And you have the date at which they were last accessed. And then the file name itself. You can do ls-lh to get more information about the size of these files. That means the H is human readable. You can also do ls-la. This will show you that there are a lot of hidden files in your home directory. This is what I was talking about. This is where you can go wrong in, kind of just installing, Python packages without following our best practices. You might end up with some hidden files that have some files that you weren't even aware of that are not according to you, and you can go in here and you can clean them out, usually without consequences. But if you have questions about that, you can let us know. But like I said, this can get wildly out of control quickly. So you'll want to keep an eye on this. So all of these that start with the dot are actually, a lot of them are pretty small, but they're actually hidden files from your normal view with ls. And so other things that you want to know, you can monitor your storage. We have a Hyak user tool called Hyak Storage. This will show you the storage near home directory. It'll show you the storage in we have a Hyak team directory, of course. And then I used to be a postdoc in the Wasser lab, and they haven't kicked me out yet. And so I can see my storage there. You should know that this is not updated in real time. It's updated once an hour. And so if you do see using Hyak storage that your home directory is full, you need to do something, and you delete a bunch of stuff, and then you go back to Hyak storage, but it hasn't been the hour, you will see that this isn't updated. So if you want to keep an eye on your storage in real time, I recommend to you du-h-d1 for looking at the first level. And this will give you a quick summary of how much data you have stored and where it is. This can be very useful if you're trying to do some cleanup. All right. Any questions about your home directory so far and this Hyak storage command? Cool. I will clear my screen, just keep it nice. All right, the next command I want to tell you about is change directory, or cd. This is how you're, visualizing yourself moving around the data system. So I can cd to the root directory. This is the top of the file system. This is where everything starts. So if I change directory to /, meaning the root directory, you see that my location here has changed now. I'm in /, I'm not in the tilde, which is my home directory. And if I ls here, I actually see all the stuff that is attached to the file system. And like I said, our mounted storage server is called MMFS1. So that's something that you want to keep in mind. If I cd and I want to go back to my home directory very quickly, I can just do a little tilde, and that takes me back to my home directory. If I wanted to go then quickly back to the directory that I was in, but I don't want to type all that out, even though it's just the root directory, it's just a slash. If I do a cd dash, that will send me back to the previous directory that I just was in. So if I do cd dash again, take me back to my home directory, cd dash back to the root. Another shortcut is cd home using a bash variable called home, which is set for you. That will also go to your home directory. Another thing, if you're very new to Linux, your friend is not having to type all of the things that you need to type all the time. There are some tricks that you can use. One is history. If you just use the up arrow, it will scroll through your history of commands so you can call back to anything that you have done. And then there's also tab completion. So I'm going to cd to the root directory, like I said. And now I'll ls again. Let's say I want to now drop into the mmfs1 and kind of see what is in there. So if I cd if I start typing mm and there are no other mms here, and I do tab, that will autocomplete the name of that directory. And then if I just start typing something like G and I tab again, there was only one G in there, we'll go back anyway. But I'm just saying that tab complete also can be your friend. One of your enemies in using the Linux command line is typing stuff out too quickly and you get an error and you don't know why, and it gives you the bonk sound, the bonk when you get something wrong. Can be frustrating. So inside of MMFS1, we have these areas that you want to be aware of. We've already been in home, which is where the home directories are for all of you and all of the users. We also have the G-Scratch directory. That's where all of our labs have their storage. You can see we have a lot of lab groups in here. We also have the student storage. So if you have a Research Computing Club account, your storage is under STF, which is right here. I can't go in there because I'm not a student. You might have dedicated storage there. We also have under G-Scratch, you have the scrub space, which is the community storage that I was telling you about. And this is kind of a mess, but it automatically gets erased every 21 days. But everyone usually has a directory here with their username that they use for their own purposes. And we'll come back to this later. Again, if I pwd, I can see the absolute path of where I am right now. If I wanted to change directory back to G-Scratch or back to the directory closer to the root than where I am right now, I can do cd .. At the G-Scratch, I can do cd .. and I'm back at the root. Any questions about, yep.
Can you, if you are in the home directory, can you cd just something that's in the root directory, or do you have to be in the root directory to get there?
No, you can cd to anywhere using the director absolute paths. So that I'll demonstrate. So if I go back to my home directory and instead of going to the root directory and then cascading down into where I want to go, I can just do cd/mmfs1/gscratch/scrubbed or wherever you want to go. So you can do it this way. And these paths will become second nature. There's also this cool thing called symbolic links. So you can make a little shortcut to go to the directories that you want to go to with just one word instead of the entire path. So for example, I've set up a symbolic link to go to the main working directory that I use. And the address of that is /mmfs1/gscratch/iacteam/fitch_kn. But I just called the shortcut kn. So when I do cd fitch kn, it takes me to, so it changes the path a little bit. So actually the full path is /mmfs1/gscratch or it's a synonym, I guess you could say. /gscratch/hioptene/fidgkn. But since I use this symbolic link and I'm just jumping, then it gives me my path as mmfs1 home fidgkn because that shortcut exists in my home directory. Does that make sense? Symbolic links are denoted by this like light blue color scheme in our directory or in our file system unless you have customized your shell. We can go back to the root.
I guess to maybe be more specific about my question, which is probably a deeply personal question, but so what? Because I just don't understand the code well enough. But if I'm in my, like on here, I see that a lot of times the code you use is like CD whenever you're going to backslash. And if I do if I'm in home and I do CD MMFS1 backslash, it's like, I don't know where it is. But if I start with the backslash, then it can route me. Can you just explain to me what the difference there is?
Yeah, so the path always starts at the root. So any of these directories always start at the root. So if you're trying to start with path, it starts with mmfs1, which you don't always have to do. You have to always put that slash there. So if I go back home and I do cd mmfs1, and even if I try to do like tab complete, it doesn't know where I am, and it says no such file or directory, that just gives you a signal that you've gotten something wrong about that address. And it's just that you have to start with mmfs1. It's just to be precise about it. There are some interesting things. So if we look at, if we are in the root, you might have seen that there are some symbolic links for common directories that you might go to. So an equivalent path to dropping into gscratch is either cd/mmfs1 gscratch. But just for convenience, we have also made a symbolic link, so you can just do cd/gscratch, and that is an equivalent path. But it's kind of confusing for users. And we have the same for our data commons. We have a symbolic link there, and for our shared software, we have a symbolic link for that one as well. I would say if you're having trouble like finding things, or your scripting is having trouble finding where your files are, using the absolute path is a like error-proof way of being able to do that. It's then the full address of where that file lives.
Thank you.
All right, so let's talk about storage, and let's go ahead and set up a storage that we can use for this tutorial. So I want you all to make a directory in the gscratch scrubbed directory for yourself, and then we'll clone the repository into it. So if I do cd/gscratch tab /start typing scrub tab, now I'm in the scrub directory. And if I make a directory for myself, I would use the command mkdir for make directory, and then I would call it my username. Don't put my username because this directory already exists and won't let you do that. But put your own username here. I've already made this directory, so I don't have to do this again. I can just cd after that directory is made into fidgkn. And now I have my clean empty directory in my workspace for this tutorial. And I want to grab the instructions that we have just to show you that I get something from the internet. And if you want to clone a repository with GitHub, you can use the command git clone https://github.com/uwrc with the UW capitalized Linux-fundamentals .dip. And that has gone out to the internet, grabbed that packet, taken it back, and unzipped it here. But by ls, now I see I have a directory with Linux fundamentals inside of it. So that'll be our directory that we'll play with. You can enter it with cd linux fundamentals, and ls to see all files that are there, ls-ltr. So he used the long format with the L flag. You can also add the T and the R, and that will give you, it will sort all of the files by time, and then it'll show you the most recently changed file on the bottom of the list. So if I'm actively working on something and I'm doing things to it and I want to find it like very quickly, I use ls.l-ltr, and then I find the thing that was most recently adjusted by myself, and it'll be listed at the bottom.
Can you go back to show the code?
Yes. I have a diagram. I forgot. I have diagram. Okay. Let me know when I can go to a different screen. So, on the file system GitHub page, I made this diagram. So it's a file tree, but it's really upside down. So it's starting with the root directory, like I said, which is called /. Underneath that directory is mmfs1, but you also have to carry this / down, right? So that's the full path of mmfs1. Within mmfs1, I put the ones in green that also have the cute shortcut, which is the symbolic link, right? So instead of doing /mmfs1/gscratch, you can, at this point, you can just do cd/gscratch, for example. Within gscratch, you have your groups project storage, which is where STF or your lab group has dedicated storage, and then you have your temporary storage in scrubbed. And right now, where we are, in scrubbed, we each have our own directory under scrubbed with our UWNet ID, and we have a directory within that called Linux Fundamentals, which we downloaded from GitHub. So now I want to show you open-ondemand. And you might be frustrated at this point because I showed you now the hard way to learn this, and I'm going to show you an easier way that you might learn it, but I think of it as a visual aid of how to do this, right? So if you go to https://. Also for you folks at home, you have to be on the VPN to do this part. If you go to ondemand.hyak.uw.edu, ondemand.hyak.uw.edu, right up here again, it takes you to the graphical user interface that you can use to interact with the file system. You have to log in, you have to get your two-factor authentication, you have to be on the VPN if you're outside of the campus network. Here you see we just linked to our blog post, so it tells you any maintenance updates that we have, but there's this files system. So I have directories in these different spaces, so it has automatically mapped those spaces. You might have scrubbed with your username here now. You should probably have the home directory. Everyone has one. You might not have these two directories. So if I go in here, I am now looking at the graphical version of what we were just doing, how we were just moving through the files, right? And this shows you the path of where we were. So if I click back, if we use this box instead, okay, it was just taking a while to list all the directories that are in there. But I can go back to home. I can go into mmfs1. I can see my gscratch is in there. I go back to the root now. We'll see what it looks like with the symbolic links. Yeah, gscratch is still in there as a symbolic link as well. But once you have a gscratch directory, it'll be also mapped in this way. So I can quickly click into my scrubbed storage, and there's my Linux fundamentals directory. And here's the files that are within that. Let's see what happens if I click on this PDF. Oh yeah, look, it will also print JPEGs and PDFs to your screen. It's beautiful. Okay, .xl, we just have to go back. Okay. If I go back to my home directory, I remember I had some JPEGs in here from the ImageNet database. I've got 2 skiers on a mountain. So this is another quick way that you can, examine the plots maybe that you're outputting or any files that can be examined this way. You can add new files, you can make a new directory, you can upload things, you can download things, you can copy and move. One thing I will say, this will only work well for small files. Big files, I have a different way. So, okay, any questions about what we've gone over so far? This is a helpful visual aid. It's like, now we're looking at the Finder window kind of the file system that you were just using to move through the directories. Okay, I also just want to point out really quick that this is where you can find, you won't have this is just for the developers, but you'll have this menu here where this is where you would set up your Jupyter session or your RStudio session or your VS Code session. And we have different videos, and you can even have a virtual desktop as well. It's a little bit slow, I will say, but you can get it to work. And MATLAB. I like using MATLAB through the virtual desktop. So even graphical interfaces are not necessarily out of the bounds of open-on-demand unless they're like very heavy, as Anthony knows. So. With few limitations, but it is the quickest way to set up your Jupyter, RStudio, and VS Code. Kai-chen's workshop on March 5th will be discussing setting up Jupyter with their custom conda environments. If that is the space that you're going to be working interactively often, I definitely recommend to mark your calendar for that or to look out for the workshop materials. If you register for the workshop but then you can't attend, you'll have access to the video and all the workshop materials as well. All right, so that is Open On Demand. We don't have a lot of time to go into it today. More importantly, I want to tell you how to get files to and from your computer. And actually, before I go into Globus, which is my favorite way, I'm going to go back to the terminal, get back down here, and oh, by the way, the thing that I just did was if you wanted to delete an entire line of text that you started typing in here, if you use Control, not Command on Mac, if you use Control and the button U, it will just delete everything. And if you're typing and you see that you've made a mistake over here on the left, then you can jump to the front with Control A. If you want to jump now back to the end, you can do Control E. And I'm not sure what the key is on Windows, but if you use the Option button, you can actually have a little crosshairs to go in this way and click your cursor into the position that you need to be editing. So now if I jump to the end with Control E and do Control U, it quickly erases what I was just doing there. Some quick stuff. Okay. So now, how do you get your files that are on your computer or somewhere else onto Hyak Klone? I'll tell you the quick way that is based only on command line first. And the key thing here is that you want to be on your local computer and pushing things into Hyak Klone or pulling things back from Hyak Klone. You have to be in your local terminal to run this operation. So I'm going to open a new terminal shelf, a new terminal window. So I'm back in my computer. And if I do, let's see, let me just... I'm just going to make a file here on my computer called test.txt. Oh, I have another one up here. Test. Anyway, just an empty file that we can use to push into the location on Klone where I want it to go. The reason why you have to be on your local computer is Klone can't talk to your computer and authenticate with it. Klone can't say, hey, I want to give you something, and then be able to put its fingerprint. There's no authentication possible in that direction. So we have to go from local to Klone. So if I want to move that text.txt into the directory that I had showing over here, I would do SCP for server copy, and then I would take that file name and paste it, space, and then you're kind of like logging in. So you do finch can at Klone.hyak.uw.edu, and then you do colon. This is now, so remember I said that you had two locations, right? You always have the computer that you're going to, and you have the location on the file system. I know that if I do a pwd over here, I can get my full path to this directory that I want it to go to. So if I copy this and I paste it over here, now it's going to send text.txt into that directory on Hyak Klone after I authenticate. Any questions about that? So this is another way. You could send this small file on open-ondemand and just like drag it into there or use the upload function, right? But this is another way. I would say if you have a bunch of files that you want to like move, put them all into their own folder or directory first on your local computer, and then you can use server copy but -r for recursive, and that will send the whole directory, all of its contents, into Clone.
Excuse me. What's the difference between SCP and get? Could I run get and do the same thing?
No, so Git is just for GitHub. So it only pulls from GitHub website locations.
Oh, I see. Okay, thank you.
Yep. So let's say so remember over here I have my entire like Linux fundamentals directory. Now what if I want to pull that whole directory back onto my local computer? It's a very, very similar command, but a little bit flipped. So like I said, to move an entire directory, you have to use scp-r for recursive. And then instead of putting the file first, we're going to put our address where that stuff is on Hyak Klone, and then we're going to offer. So we're going to log in again. finchk at clone.hyak.uw.edu /. Let me just go back here. Like I said, it's better if you copy and paste instead of making mistakes. Oh, but I see I already have a mistake. So I can use my little crosshairs and delete this extra slash, and then I can jump to the end. So if I want that full Linux fundamentals directory to move into my computer, I just say dot for here. Like take that which is on the server, this directory, recursive, everything that's inside it, and move it here with the dot. That's how you shorthand that. You have to authenticate again. And it copies all your stuff. That's a lot more than I thought was going to be in there. Oh, it's all the, I remember, there's a directory with all the images, right, that I use on the reco. So it's all making sense. Anyway, if I do ls-ltr, I have my Linux fundamentals directory. You can list things while you're not inside of them, okay? If I do Linux-fundamentals, I can also list without being inside of that directory too. That can save you some time. I can do the same thing here. If I go back to finchcan and I see that my directory is there, I can list it without being inside of it. I can also list recursively. This will show me what's inside of any directories that are inside. So it's showing me all of the files that are in there at the top level, but then it will drop down inside of the image directory where I have all my screenshots and stuff that are used on the GitHub repository. Okay. Now, I've shown you 2 ways to get your stuff on the higher, but I have one more way, okay? I don't, it's a lot, but this is the best way. And this one, you'll have to set it up on your own, following the GitHub instructions, because there is something that you have to set up the endpoint on your own computer to be able to see the files in your computer and do this move. So for right now, just follow along with me. But I'm gonna log in at globus.org. And it's showing the 2-pane view here. So it usually by default shows the 1-pane view, but I always like to see the 2-pane view so that I can see the 2 sources and destinations that I want to transfer things between. I have my bookmark collections here. So Hyak Klone, Hyak Copa, and Hyak Tillicum are all 3 collections that have closed endpoints. So if you're a user on Copa or Tillicum as well, this is also valid for that. And I have my computer set up as an endpoint. There's one other collection that I want you to be aware of, which is UW OneDrive, where I think all of you have OneDrive, where I have my files and everything like that. Even my shared libraries are here. So if you have shared with your lab and everything like that, you can use Globus to transfer between Hyak Clone and your shared OneDrive or SharePoint sites of your lab, for example. All of us get 5 terabytes of OneDrive storage for free. And if you start a SharePoint site, you get 25 terabytes of storage. People are not taking advantage of this. All right, so anyways, I'm going to go back and set up per endpoint to be Hyak Clone on this side. And then I'm going to have my computer on the other side. This is the thing that you have to install for yourself after this tutorial. So I'm going to drop into the directories like we were doing before. Go mmfs1, gscratch, go to, I'm just going to do this way, faster. So you can put it in the path here, faster than scrolling, Linux fundamentals. And then on this side, I can get the destination set up. So I'll just bring it to my desktop and I'll pull that slide deck. And now if I press the start button, it does transfers. One thing about Globus and what you really need to know is that I've shown you open-ondemand and SCP. These will take advantage of your laptop and you basically have to be connected to the internet the entire time for that upload to happen. So it's not great for big uploads or downloads. Globus has unsupervised fault-tolerant transfers. So if you have something really big that you need to transfer, do it this way. It will tell you that this is happening and it'll send you an email when it's done. There's also some options for transfers. You can encrypt the transfer. You can do scheduled transferring. There's a lot of options here. So Globus is definitely the way to go. If I wanted to go the opposite direction, let's see. Got some random screenshots. Oh, some Globus screenshots that I can transfer on the other side. So one thing to note is it won't let you press this button if you have something selected on both sides. So you unclick that side. And now if I want to transfer from my computer into Hyak Clone, then that transfer is happening. And if I now go back to the command line and do a ls, and I go into Linux, then I see that find collections ping is just a screenshot that I used for developing this tutorial, has now been transferred to Hyak Clone. Okay. That's the first hour of Linux fundamentals training. Anyone have questions just so far? What we've done?
I'll ask a question.
That's great. Yeah.
Because my terminal crashed when we started this process. So will you just reorient where I should be to continue?
Yes.
I'm logged in and I'm in Scrubbed.
Oh, you scrubbed. Okay. So did you make your directory with your user ID?
Yeah, I can see that it's in.
Yeah. Okay. So you want to cd. It's about another shortcut is you have another variable that's called user. So if I cd into scrubbed, where you are. If I cd into user, and then the only directory that I have in there, oh, it won't work that way. Sorry. If I cd into user, it just finds my net ID and it replaces it with user. It's just a bash variable that we all have set up for ourselves. And then if you cd into Linux fundamentals, then you're back where you should be in your directory. Now we're going to do rapid fire other commands. But I can slow down too. Is the pace okay? Because so what if you want to get something from the internet that is not on GitHub? We have a command for that. It's called wget, meaning web get. Get it from the web. And what we're going to do now is while we're in our Linux fundamentals directory, we're going to download some test data from software-carpentry website. And some of these exercises were based on software-carpentry, but I put them into a flow that I like to help our users. So I'll slowly type the command into the terminal, but if you have the GitHub repository open to 06 basic commands, there is a wget command. And if we were further along, I would tell you how to quickly get that command from this markdown file right here. Okay, we'll just do a teaser. Okay, so there's this command called grep, which grabs regular expressions out of files and lists and directories and everything. So if we grep quote wget from 06, let's see what happens. So it's printed me all of the lines, and this is coded in Markdown, so it looks kind of weird, right? But it grabs all of the lines where I use that command wget. We'll talk about grep a little bit more if we get to it. There are exercises here for grep. But this is the command that I want. So if you ran that command, now you can just grab by copying and pasting that wget command. Hangst. So that just went to the internet. And it is pulling from a GitHub repository. That they are recommending a different way. Anyway, I want to show you wget. That's how you get from any website. And it's put into my directory zipped up file. So let's see what we have now that we ran that. Oh, it has an old timestamp, but it's here. So it's in red because it's zipped. We have to unzip it with the command unzip, of course. And it's just told me that it's inflated all of these things. Be careful on your storage management, right? If you download something that's going to be really big from the internet and it's already really big that is compressed format, and then you unzip it or you gunzip it for the DNA sequences, then it will be larger. So you want to know that the storage at the source is going to be enough to hold the zipped version and the unzipped version until you delete the zipped version. Anyway, so now let's see what we have here. We have now the unzipped version of the shell lesson deck. All right, so let's go ahead and start exploring that. So we'll cd into shell lesson data, ls. We've got some exercise data. That's where I want to go. cd exercise data. And then there's writing inside, so let's cd into writing. Oh. There are two files in there, one called Haiku and one called Little Women. This is the entire novel of Little Women, if you want to print it to your screen. I already told you how to make directory, but let's go ahead and make a new directory called thesis. And then go into that directory called thesis. And one additional thing to talk about with the make dir command is that you can make the directories on a path with the nkdir-p. So this, you can give it like the full path or the relative path for where you want to create those directories. You don't have to be inside of their final destination to create them. So if I tell make directory that I want to in one directory closer to the root than where I am. So if I go up one directory into writing, where I came from before, I can make a directory in there called projects, and I can make a nested directory inside of that one called data. I can also make another one in the same line of code in the project file. I can make a directory called results. So then if I cd and ls, now I have my directory with project And if I ls-r, it will show me the directories that I have here, and it'll start to kind of tell you what's inside. Be careful of this. Like I said, if you have a directory that has a lot of stuff in it, it's going to print that all to the screen and you'll get the bonk noises. Okay, let's go back into thesis. So what if you need to edit a text file in Linux? You can't use Microsoft Word. You can't use any of those graphical things. There are some things that you could use in open-on-demand, but you're using the command line and you need to edit a file. Well, let's see how we do that. So the first command I want to show you is called touch, which allows you just to make an empty file. I'm going to make a file called draft.txt. So now inside of my thesis directory, I have a file called draft.txt. And I want to use the text editor called Nano to open this file. There's also text editors called Pen and Vi, and they're a little bit more advanced. Some of the, you really have to practice with it. I recommend looking up a YouTube video before you go down that route. This one we think is a little bit more user-friendly. And I could write anything here. On the software-carpentry website, they have some like very cliche things that you can write. It's not publish or hairish anymore. It's share and pride. And so if I have done that and I want to save that, I would use the control. So this little caret symbol sometimes can mean control. So I would hold control and then the O button to say write out. And it's just checking with me that it's okay to save this as draft text. And I can say yes. And then if I want to exit Nano completely, I do Control X for exit right here. Control X. And then that leaves. And now I have my draft.txt is there. And what if I want to print something to the screen? I keep saying that. The command is concatenate or cat. So there it prints what I wrote. All right. Like I said, printing things to the screen can be troublesome. If some of you are working with DNA sequences that are in a fastq.gz format, do not print them to the screen because they are in and zipped up in certain ways, and it'll just be funk, and then you have to, and something like that is happening. If you do Control-C, 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 and it'll just stop the process. So that's like your kill switch. So if I had a longer we do have some longer files. So one thing to make note of is that I can't cat anything to the screen that I don't have in my current directory. So for example, there in a different directory in the shell exercise data, there is a DNA sequence fictional from the Harry Potter universe called basilisk.dat. And so if we go up a few times into exercise data and we ls, we see that there's creatures here. So by cd creatures, we have some fictional characters. And if we cat basilisk, then it's a long file, not too long. If you do have like an exceedingly long file and you just want to like kind of march through it, I would use more for basilisk. And this will start, and you can use either the space or the return key. Space will jump more lines, and return just jumps a few lines at a time. But once you're in that, you can't get out, so you have to do the escape, or sorry, not the escape button, the Q button. And that exits the more command. There's also a command called head with basilisk data, which will just by default print the first 10 lines. Similarly, there's tail, oh, not tile, which will print the last 10 lines. And then if you just want to print, the first 3 lines, you can do head-n basilisk dat, and it will just print the first 3 lines. So these are commands. Quickly look into your data. But like I said, we made draft.txt. It is somewhere else it is in the thesis directory, right? We made that thesis directory. If I tried cat draft.txt, it is just not here. One, I can't tab complete. It will say no such file if directory because I haven't given it information about the address of that. But since I know where it is, if I go one up and then drop into writing and thesis, I'm giving it the relative cap to where I am. Oh, that's not right either. That's something. So if I start getting tab, it will kind of list what I tab. So I am going into writing. And then what else is there? Thesis is there. I must have spelled something wrong. And then, oh, I see. It's because I'm trying to do a directory, but I wanted it to cat. So if I give it the relative cat, so compared to where I am right now in the creatures directory, if I go one directory up and then cascade down into writing thesis, then I could print draft. So this is what I was talking about before. You want an absolutely fair, error-proof method of where these things exist is to give the absolute path. So that was a relative path, noting the little ... slash and saying relative to where I am. If you go one directory up and then cascade down, you'll find draft.txt. But if I go cat mmfs1 gscratch scrubs bingecan Linux shell exercise, what is it? Exercise data, writing, thesis, draft. In your scripting, while you're running your Slurm jobs, if you got scripts in one directory and you got your data in one directory and you got your results in another directory, use the absolute paths. It will just save you time and it will always know where the things that you want are. You don't have to trust that you're executing that script in the right space. It will just be able to run. That's maybe out of context for where we are right now in our learning, but it can be helpful. Okay, any questions? Those were pretty easy ones. Few more commands. Let's go back to gscratch, scrubbed, bitchcan. Go back into the top directory of where we're working. So gscratch scrubbed bitchcan using the symbolic link for gscratch here. And I only have the Linux fundamentals directory. If I wanted to copy a file that is somewhere on the data set or on the file system into my current directory, I would be able to use the copy command for cp. And there is some, just test data that we have access to in the software directory, which is like our shared software and resources directory. Basics, data. There's a file called animals.csv. And the same thing with server copy. If I wanted to copy from that location on the file system to my current directory, I just use dot. Now I have my Linux fundamentals directory and a copy of animals.csv. If I wanted to copy an entire directory, the same thing goes that I would need to use. So I'll just use this same command, it's template, remove this, and I'll just copy the entire data directory to here with that dot, but I need to add the -r flag for recursive. So it grabs the directory and everything that's inside and copies it here. And if I wanted to rename the animals that rename a file, I would use the move command or mv, and I would get the file that I wanted to change, and now the new name that I want to use, and you could name it dataset.csv. And now animals.csv have been renamed to dataset.csv. And if I wanted to remove a file, caution, this is permanent. We don't back up storage on Hyak Klone at all. It's your responsibility to back up any of the files and storage that you have here. So if it disappears, we cannot make it come back. It's permanent. So, but I don't care. I'm going to remove dataset.csv with the rm command. And now it's on. And if I needed to remove an entire directory, I could do that with rm-r, again with that recursive flag, with the data directory. Don't remove your Linux fundamentals directory just yet. And it would do what I say without any failsafe. So be careful with this. All right, and I told you about the touch command a little bit ago, but you can also make multiple files with a single line of text or a single command one-liner like this. So now I've made all 3 of those files. Okay, those are the super basic ones. And now we're going to have a little bit more fun with a bit more advanced commands. Any questions so far about what we've gone over? I know it doesn't seem very in context yet because you're not working with your actual data, but hopefully it gets you somewhat in a, onboarding some tools and toolbox you can kind of get started. You can always refer to the materials along the way. And talk to us, come to a talk sounds. Okay, so there are things called wildcards in coding too. It's a way to refer to multiple items at once. So if you wanted to list, let's touch one more file, and let's touch file 10.txt. Now we have these 3 files. If we wanted to if we had a big list of these and we just wanted to filter and find the files that have 1 digit. So it's file and then 1 digit. So the 1, 2, and 3 in this context, we would do ls file and then question mark. Question mark is a wildcard for any single character. So that would just list those 3, and it would not list the 1 here, or the 10, file number 10. But we could list a range of files. So if I go back up here, another way to list the same set of files would be to do the 1 through 3. But you could also do 2 and 3. So these are great for your single commands. It doesn't, or your single characters. It doesn't work for multiple characters. So if I did, well, let's just try it. So if I did file 2 through 10, it doesn't like that. It cannot access 2 through 10 in this directory. It's just, this set of commands only works for single characters. But if I wanted to list all of the files ending or starting with file, I would do ls and then this wildcard, which is a star. Sorry, I would do the file star. And that would give me all of the files. It wouldn't show me my directory Linux fundamentals is in there anymore. So when to exercise extreme caution with the wildcard is when you're using remove. If you rm star all of those files in your current directory will disappear. So be careful. If you do rm file star, all of the files that start with file in this current directory will disappear. Okay, so be careful with that. It's a lot of power. Okay. Do we have any more? I think the wildcard is kind of clear. I have like 3 more commands I could show you with it, but I think it's... You can put it at the front and the back of the command. Let me show you one more. If we ls from the software directory, Hyak 101 materials, basics, we ls that entire file, that is the other thing that is in there. But if we just wanted to show all of the slurm template scripts that are in here, we could do star.slurm. And that would just list all of the slurm files that are in there. We could also list just the ones that start with locator. And that would show us those files. It's pretty clear, right? Wildcards, you can... There is probably a context, but you will use that. Okay. Let's go back into our Linux fundamentals directory and into our shell lesson data. And into the exercise data directory. That's ls to remind yourselves. There is a file in there called alkanes. Where we have a list of... Okay, let's see what one of these looks like. With the more command, we can scroll through it. Oh, it's pretty short anyway. So, it's just some sample data here. If you had a dataset and you wanted to know, maybe it's a dataset of observations, and you wanted to know how many observations are in there and how many rows are in your CSV file or something like that, you could do that with the word count command. With word counts and then giving the name of the file. So word count by default is showing you how many lines, how many words, and how many bits, which I don't think is very helpful piece of information for me, but it's there. But you have 15 lines in this. If you wanted to filter the output of the wc command, you could use -l, which would just give you the number of lines. We can also double up on these commands. We can get the number of lines from all of these files and this directory. We can say wc-l and then we use our wildcard .pdd, and it gives us our list of each file, the lines that it has in each file, and then the total number of lines if you concatenate them all together or sum them together. So what if we are using this and we need to output this, not just to our screen, but we need to do something with it after? We could save the output. Let's just use our up arrow to go back up to this file. And we use a redirect command, which is just the greater than symbol. And we call this lengths.txt. And cat lengths.txt. Then we have our new file that's called lengths.txt, which contains the lengths here. Okay. And if we wanted to, we could, I don't know why you would do this, but if you wanted to, you could append the contents of another file to lengths.txt. So let's say we want to take lengths.txt and just append what's inside of metapdd to it. We would cat lengths.txt and then we would do a double redirect, which means append, and we would call it lengths_methane dot. Oh, I spelled methane wrong, sorry. Try it again. It just appended the lengths.txt. Oh, I know what it did. Sorry, guys. Sorry, just big mistake here. Let's try the append command again, and let's not go off scripts this time. So let's go one directory up, back into exercise, and go into animal counts. We have our animals CSV here again, which just gives a date and an animal that was seen and how many times it was seen. And we can do, on that day, we can do a WC-L with our animals. We have 8. We can do if we wanted to subset this, we can do head-3 animals.text and redirect that into animals subset. I don't know why it gave me an invalid number then. Oh, I see. Because I didn't give it the number of lines that I wanted. Here we go. And now, if I wanted to append just the last 3 lines to this animal subset, I would do tail-n3 animals CSV, and then append with the double redirect to animals subset. And then I would have the first 3 lines of that and the last 3 lines of that all in one file. Okay. Let's see.
Why the double redirect again?
It's to append. Yeah. So if you have the existing file and it's if we did just a single redirect, it would only take tail and the first 3 lines of that, and it would just make a new file. It would overwrite our previous file in hull animal subset. So if I wanted, you could do that with just one redirect. But if we wanted to take the first 3, last 3, and append them both and use this command. All right, I want to show one more command called sort, and then we'll degrep. Okay. So if we go up one directory into exercise data, there's a text file here called numbers.txt. Let's see what is in there. We just have these numbers. So if you sort this numbers.txt, it is going to sort those numbers and print it to the screen, but in sorting it in lexicographical order, not in actual numerical order. So to sort in numerical order, we need to do -n with numbers.txt, and then it will sort it in the logical way that we usually think about sorting numbers, which is starting with the smallest number first. One thing to note is that if we still cat numbers, it hasn't overwritten it hasn't sorted those numbers in place and overwritten the sorted version of those numbers. It's not done anything to this file. It's just taking the input of what is inside of numbers.txt, sorting them, and printing them to the screen. So again, if we wanted to sort that, we would have to redirect it, and then we have sort in numbers. So sort-n numbers, we would have to redirect this, call it sorted.txt. And then we have our sorted list of numbers. And it's going to sort numbers first, and then letters alphabetically, and then it will do lowercase letters after. But there are options with the sort command. So if there are any commands that you want to know what are all the flags, you can always use --health. and that will print out the long format version of all of the help options, the usage, it'll give you usage hints here, and then it'll give you all the options and what the defaults are. So that is your friend. Also, if you use man with the command, it will open up a separate page. So it'll bring you actually into a viewer of the help file instead of printing it to your screen. And to exit this command, just like you're using the more command, you have to use Q to quit. You can also link together commands using the pipe character. So if we go back into alkanes and we use wc-l like we've done before, and our wildcard with all the files ending in pdb, we can use the pipe character, which for me is above the return key. I use shift to change to the pipe character rather than the backslash. So we can go sort-n with that. So if we just did, sorry, let me do this way first. So without that part, it sorts the word length, but in the lexicographic or in the alphabetical way first, and then the numbers. My notes were incorrect. So it sorted based on alphabetical, and then it didn't sort the numbers, I guess, at all. Oh, I didn't add it to sort. So this is how the file is straight up. It's just, this is how the data set is before being sorted. If we sorted it in the numerical way, it would start with the numbers and sort them numerically. Okay. So what I did was I took that word-lock word count with the lines command, applied it to all of the files ending in PDB, and then asked it. It took the output of that and immediately put it into the sort command, so I was able to chain together these two commands at once. And you can also output that. So after that, you could chain together with a redirect command and call a file sorted-lengths.txt. And it would just save that output as a file. Okay, any questions? Okay. Now we're gonna talk about grep. I really like grep because it makes me feel like there's a bit of instant gratification when you are working this and you're getting a command and you're doing something cool, and I think grep is a cool command. And it might be able to help you filter some of the outputs that you need or quickly find things. The way that we used it earlier, we used grep to quickly, in the markdown instructions for this tutorial, find the lines that started with wget. So we were able to copy that and paste it in. So if you're keeping like notes on Hyak with all of your commands, maybe that is something that you could use to quickly grab things so you avoid errors by using copy and paste. Alright, let's drop down again. We're going to go back into exercise data, but then we're going to drop into writing, where we had some files like I talked about, Cork, Little Women, and Haiku. We can use the command grep to find all the occurrences of the word THE with a capital T in Haiku, but actually it will give you not just the exact word matching the word length and just that, it will find all cases of capital T, HE, even if it occurs in other words. So if you wanted to find an exact match of the word THE in the Haiku, we can use our up arrow to go back to this, but we can just add a -w and that will find the exact word, so that only occurs one time as a single word in Haiku. And once I just check out Haiku, then we have our proof that it is only here in the first line. And what if you wanted to not just grab one word, but you wanted to grab a phrase of multiple words? You could do that, but it wouldn't work this way. It's just going to find the first word that you are asking for, and it's just going to ignore this word completely. But if you wanted to find them So if you just wanted is not, but not to have this line, you would need to put quotation marks around that. And that would give you the only occurrence where these two words are together. You can also have it tell you which line the word occurs on. So if we grab this same option, the same command, but we add -n, now it's going to say this occurs on line 10. So if you have, in your Python script, and it's very long, and it says you have an error at line 360, that can be fun. Well, you can see if it tells you a little bit about the text, then you can grab out the text specifically, and if it is occurring more than once, you can add the lines so that you can find the time that it occurs on line 326. And you can combine options. So if we did -n-w with the with a lowercase. So I made a mistake because I accidentally pressed return, and now it's giving me this thing, and it can be hard to get out, but you just remember we have our failsafe as Control-C. So I'll try again. B for haiku. And now it's telling me the exact matches of the word be in haiku and the lines that it's occurring on. You can also have multiple flags that don't have the double dash and option. Okay. You also have a recursive option with grep. So if you do -r and you look for the word yesterday, in here, it will look through all files and all directories to find the word yesterday. And so it finds the word yesterday once in haiku and 3 times in Little Women. And if I wanted to know the lines in each of those where it occurs, it's added the line number as well to the output. You can be carried away, right? So you can do, if we did this same command here, but with the recursive option here, you get all the times in Little Women that the word be occurs. Not very useful. But I'm just saying that you can really print a lot of things if you are trying to find something in a DNA sequence and you do the word A or the letter A in a DNA sequence. It will just print that like potentially terabytes file to the screen. Be damaging. Okay. Another command that is great to use is your history command. We're already using history, right? Our history is attached to the up arrow and the down arrow, so we can scroll through our history. But if you use history, it will also print this to the screen. Another fun thing about this is now while the history is printed to the screen, if you do a exclamation mark and one of these numbers over here on the side, it will rerun the command that you wanted to do. So if I want to do exclamation point 5275, it will rerun the ban command for sort, and it will show me all the options for sort, which I can use Q to exit. And the quick speak for this is to do bang and remember. You can chain together the history command with pipe character into the grep command and search for a particular word that you use. So let's find all the times that we had cat commands today. Right there. So this is a way to filter your history outputs to find the specific things that you're looking for. And lastly, the find command is also useful if you want to find in this directory all the files that have a name that ends with wildcard.txt. Then it would list all the files and it'll drop in to the directories to find those files that went into the thesis directory and found drop.txt. Another thing that can print a lot of information for you if you don't want that. Just be careful with that one. And you can use grep and find together to find the word searching. This one is a little bit more advanced, is using kind of command within command. I'll explain in just a minute. So we're using grep. I want the word search. I want to find the word searching. Grep the word searching, but after you've executed, so the money sign in bash usually means execute. That's why we have it here. It is this ready to take a command and execute it. After executing the find command in this directory on all of the files that end with .text. So it's going to look in all the files and try to find the word searching. So similar to what grep was doing alone, but if you had many more files and you just wanted to look in files that are .text and not anything else, then it would go into those files, find the occurrence of the word searching. And it only occurs one time in the web. All right. So we only have 7 minutes left in our allotted time for today. And I'll do a little bit of the task and leave the rest of the task for you all to do on your own. The one thing that I want to show you of the task is how to start an interactive compute job. We have trainings on Slurm in particular. Is a little bit out of scope for today. As you've seen, we've gone through all of these basic commands and we're almost at the end of time. But if you're doing computing and you need to do a larger process, you're not allowed to use the login node, or if you do, it could start getting hit by arbiter, which is going to knock down its processes. So instead, you want to start a job on a compute node, which means that you're requesting a job on the job scheduler from the job scheduler called Slurm, which manages all of the servers as resources. And so if you want a interactive job, you would use the command salloc, and you would give it a partition. To use the community idle resources, you would use partition ckpt. There's also ckpt g2 to just use the generation 2 hardware, or ckpt all if you don't care about the age of the hardware. But just regular checkpoint cpt checkpoint is the older generation hardware, CK. Then you can give it a time. So this is the maximum time that the job will run unless you end it before that. So we could put 30 minutes. The time always goes in as hour, minute, seconds. So if you put 1:00, it's not 1 hour, it's only 1 minute. You can ask for the amount of RAM that you need. It always has to have the units attached to it, or else it will automatically give you, I think the default is that it gives you 1 megabyte. So you should probably march that up. And if you only say 4, it will default to megabyte and it'll leave you 4 megabytes, which is not very useful. So it'd be 4 gigabytes. That is better. And then you can do CPUs per task and just ask for 1 or ask for multiple if your job uses multiple CPUs. Oops. I spelled partitions wrong. So this submits a job. It will default to your account. So the first account that I was ever added to is the Wasser Lab account. So it defaulted to Wasser, which is okay for now. But if you have multiple accounts, you would just add -- account equals and then that account name. And it's waiting on the resources right now. I haven't looked to see how busy Checkpoint is today. As I said, with the community idle resources, wait times can vary. That was pretty fast. But now you see I'm not on the login node anymore. I'm on a node called N3319. And I'm still in the writing directory. So all of the files that we've been exploring this full time, they're mounted identically to all of the compute nodes as well. So what you've learned today is valid on the login node and is valid on your compute nodes. So when you're starting to do your work and you're requesting your jobs, you're using the same set of paths that you've learned today. The same set of paths are available on the compute nodes. So that's an interactive job. There's also batch jobs. So if you have a long-running job, you would want to set up a batch script to submit that job with the parameters that you wish and also the commands listed there. We have a Slurm tutorial on the website. You go to Learn, you see it's Learn and Advanced Slurm, and in winter we'll be having a Slurm training specifically. But there are videos associated with these. They're a little bit outdated, but they still work. And then Tillicum has its own Slurm tutorial as well. We have a quick video about Slurm, which might be useful for you to kind of get started. One thing to note, so I'll exit this. So once you exit, you're relinquishing that node. Also, if your connection drops, then that job is ending as well. So if you want your job to continue past what you're doing, you need to do other things, but the best way to handle that would be to submit it as a batch with the command sbatch and then giving it your Slurm scripts. But if you don't know what resources you have access to, we have Hyak user tool called Hyak Alok, which will print to the screen the accounts that you're a part of. So I'm just looking at my account. I'm a part of UWIT. You all should also see UWIT attached to your accounts because you're participating in this workshop. I will be removing that access on Monday morning, but you have priority access through UWIT and any other priority accounts that you have. And if your account only says demo, then you have to use the checkpoint resources. Another thing that Hyak Alok tells you is how many of the community resources are idle. And it tells you of the partitions that you can choose from, how many of them are used or are free versus how many are used. So we just deployed a full bunch of equipment, and we're a small team and we're not doing computing every day. So there's a lot of our CPU G2 options there. So over the weekend or this afternoon, if you want to do more tutorials, do the task here, which has some like quick additional grep and filtering commands, then you could start your job in the following way. Salok again to start your interactive job. But this time, use account equals UWIT. And partition, this is where this comes in handy. I can see the partitions that I have access to. So I have even some L4ES GPUs that might be of interest to you. But I'm going to go ahead and do a CPU G2, which are the new AMD Genoa computers. Paste that right in there. Time, you can put whatever you want here. I'll just put 1 minute since we're almost done here. And CPUs per task equals 1. A lot of these also have short versions. So if you do -A, that also equals a count. Actually, I'm going to do this a little bit longer because I want to show you something else. So for 5 minutes. And this is where you shouldn't see a lot of wait time. So as long as the resources are available, which all the resources in this partition are available to me right now, then my job should start almost immediately. If you find yourself waiting half an hour, you should let us know. There might be something else going on. Under a higher load on the cluster, wait times could vary. Or if you request a very, very large job, multiple nodes, for example, then you might be waiting a little bit longer. So I wanted to show you just one more Slurm thing. I'll exit this. If you want to look at the jobs that are running on the cluster right now, you can use the command sq, and this shows you all of the jobs that are running right now.
So where does the signal start? Way up here.
So the cluster not idle. It's also really neat. Well, anyway, you get the idea that you can see that there is a lot of information here. All jobs are given a job ID. This one is an array job, so it also has sub-jobs from it. But if you have a particular problem with your job and you open a help ticket, the job ID can be really helpful for us to go and investigate what's going on. So if you find something is wrong, if you keep this job ID, then we'll have a faster time helping you. Yep.
In a case like this where you printed a huge amount of stuff, is there a shortcut to go back to the command line?
You can do clear.
Just clear. Okay.
Yeah, let me do SQ again. So I think if I scroll way up here, if I just start typing, it will just bring me back down to the bottom.
Okay. That there's not a fast way to like go back to your SQ command line. Does it pop back up there?
Well, it's just right here.
Okay.
I'm not sure what you mean.
Like if I wanted to see the command line that brought this,
Oh, okay.
is there a way for me to just like pop back to that?
Well, you can use your history like scrolling back, or if I did history grep, I do this all the time as a log, then it will show me all the times that I used SLO. You can do it with the default options if you want, but if you oh, whenever I do a GPU job, I always use, this is my command, and then you can like remember these things. You don't have to remember these things. You can find them in the history. And then if you just want to see your jobs that are running on the cluster, which I don't have any jobs running right now, let's just see. If I wanted to look at all of the jobs that this user is doing, I could do this. So they only have one interactive job running right now on a older GPU. Does anyone have jobs running on Hyak right now? Okay, I must stop now because that is time. But thank you so much for coming, and hopefully that was helpful. We do have our feedback form, which is linked on the repository, but I'll clip the slide up. We appreciate that feedback. It helps us to make this better